Hello students, here we are for our lab for carbonate equilibrium, and I will be performing an experimentation in front of you, but like a few blip about the introduction. So the aqueous carbonate equilibrium is challenging subject, yes we all know that, but it's important and necessary just because it helps us in understanding the carbon cycle and for of course lately the impacts of increasing CO2 in the environment. So equilibrium reactions of the, or in other words, the equations for the dissolved carbon, they're really important to understand because together they form a regulatory mechanism that help us understanding the global carbon cycle, and they often control the pH of the aqueous environments. So assessing the carbonate system in general is really important, at least for the environmental scientists, because it reflects the changes that are happening in the atmosphere. So in the aqueous solution, because this will be involving the experimentation that I'm going to do, and you need to understand a little bit about the reactions that happen within the carbonate equilibrium. So in the aqueous solution, I'm just emphasizing because we are doing this for water. The major carbon reactions that occur and the species that are, it's CO2, and then that changes to bicarbonate, and then that further changes to carbonate. Okay, and just keep in mind all these reactions are interchangeable, and this is where I'm going to emphasize again, and what triggers the interchangeability is the dissolution of the CO2 that comes from the atmosphere in the seawater. Okay, and further they further change in from CO2 gas to the aqueous one. It involves the stepwise protonation of all these reactions. Okay, so now here we are. I'm just going to pinpoint towards the experimentation that you will be involved in. This is a titration. Well, yeah, of course, there's a burette. So we will be doing pH titration. And today, the titration, we will be using the solution. This is the artificial seawater that has been prepared in the lab. Okay, it's not from the ocean, but we prepared that in the lab. And I have added the sodium carbonate in it just to add some buffer in the solution, because natural occurring seawater has calcium carbonate. So we can definitely use calcium carbonate to make a lab experimentation, but for us, I just added sodium carbonate. Okay, so I have already prepared this one just to kind of show you guys that it's not clear anymore just because it has carbonate, so it's a bit cloudy. Okay, so the same solution I have here in the experimentation right here. So I have added 50 milliliter of artificial seawater that I just mentioned, prepared in the lab, and I have added 0.5 grams of sodium carbonate in it. Again, 50 mils of seawater and 0.5 grams of sodium carbonate. And as I said, we can use calcium carbonate as well, whatever is available. So at the end, all we're interested is in the data that we're going to collect. And I'm going to use the acid, and in our case, I'm going to use the H2SO4, which is the sulfuric acid, and it will be 0.1 molar. So it's kind of not too weak, not too strong, but it serves the purpose for us. So that's what we will be performing. And I just also want to pinpoint on the data sheet that we will be filling as we go. I will be titrating, and at the same time, I will be recording the data for the change in the pH. That's why you see the pH meter here as I add the acid in the seawater and the carbonate solution. So we will be recording the change in pH plus the volume of acid that I'm adding. So those are the two set of data that we are collecting. And by the way, this data I will be sharing with you eventually, and you will have access to this by now. And you will be treating this data further to perform some calculations, and we will be graphing this data to find the equivalence point and the half equivalence point, which is pK1 and pK2, which will further assist us in calculating the concentration of carbonate and bicarbonate ions. So a little introduction on the pH meter, because I'm not going to calibrate in front of you. I have already calibrated this pH meter using 3-point calibration, which means I have used 3 buffer solutions starting from the acid one, which is the pH 4, and then I use the neutral one, which is the pH 7, the yellow solution, and then the basic one, which is the pH 10. So you have seen these already, but just a little quick introduction that what involves in the pH meter. So I have calibrated it already. So this is what I'm going to use to take the reading for the change in pH as I'm adding the acid in my buffered solution right here. So I'm just going to start. So the way I'm going to take the reading, I'm going to set up my pH, the volume that I'm going to add in the burette. To start with, there's a bit of, you have to come up whether you want to add 1 ml, half ml, or 1.5. I'm going to start adding 1 ml and 1.0 ml and see how it goes in terms of my readings for pH. And then if we have to change, we can always come up and down a little bit depending upon the set of readings I'm interested in. And as I said, I have already prepared the solution. Just to remind you, I'm just going to kind of agitate it a little bit just so that I get the initial reading. So I'm just going to stir it so that my carbonate is dissolved completely, as it's been a while I added, kind of make it a homogeneous mixture. And then I will wait for my pH to give me the initial reading before I start adding the acid in my solution. So the first reading I got here is, for my solution, is 9.91 and nothing added, no sulfuric acid. So that's our starting point. Okay, and now here's the deal here. So I will keep adding the acid into my solution because I want to go to the pH either 3 or a little below 3. I'm starting approximately 9.9, which is 10, and why I want to go all the way to 3, just because remember in my introduction I told you that the aqueous inorganic carbon has 3 different species of our interest, which is CO2, bicarbonate, carbonate, and that's what we are trying to achieve, because all these 3 species of inorganic carbon, they occur at different pH. Okay, so we are starting with the carbonate because I just added the carbonate, which will be at the higher pH, which is 9, and as we move from carbonate to bicarbonate, we will be in the middle somewhere, and I'm hoping around 8 or somewhere close to neutral, and eventually when we are at CO2 species, we should be really, really acidic in our solutions. So that's the whole point of this experimentation. So as I said, I'm going to start with 1 ml. And my starting point is, I'm not starting at 0, I'm starting at 10. So that's how I'm going to start recording. And you can do the same and see after adding 1 ml how far I am going in my change in pH. So I will be focusing more on a burette this time and slowly add 1 ml. And just to remind you, for liquids, we go with the lower meniscus. So I will keep an eye on the lower meniscus. And in case you feel like, okay, well, you just shot like me, you can move your burette to bring it to your eye level. Okay, here I am. I just added 1 ml of acid into my solution. And as I told you earlier, the data set involves this and plus the change in pH. So I'm going to keep looking at my pH and wait for it to give me the change happens from 9.91, which was my first reading, until I add this 1 ml. Okay, so the reading I got was 9.84, so it is dropping down. So what I'm thinking, I'm going to go further using 1 ml. Because I'm happy with the change it's showing me so far, and see how it goes, and if I don't have to change, I will stick with 1 ml, I guess. So the important point here is to make sure before you start looking at your pH meter, stir it, because you want to mix the acid you are adding to your solution here. You can move the probe a little bit and then just give it a gentle stir, and then just leave it alone for it to stabilize so that pH can give you a reading. pH meter can give you a reading. So this was another ml that I went down. So I started at 10 and now I'm at 12 ml. So far I have added 2 mls. I like going really slow. Oh, sorry. We got the third reading. Just because we don't want to miss those equivalence points. Remember I told you in my introduction that you want equivalence point when carbonate is changing to bicarbonate, and then the second one will be your when bicarbonate is changing into CO2. So we don't want to miss those important equivalence points. So go slow with the volumes and then make a change accordingly if you have to. So this is going to be my third reading now, and you know what? I think I'm going to stick to 1 mil. And it's really normal in the lab experimentation to do a bit of a hit and trial, okay? And sometimes we have to restart, and that's not a big deal at all, I guess. So that was my third mil, and I'm stirring as before. Gentle, vigorous, not too vigorous. And then let it stabilize so that pH meter can read for you. Okay, I'm going to continue taking few readings, and then I want to comment on the way the solution is going to look like eventually as I keep adding more acid. Okay. I'm going to let pH meter do its thing. So what's going to happen as we move further into adding more acid and acid into our solution, you will see the cloudiness or the white, it's a bit cloudy and it's a white solution because I added carbonate in it. It will start turning transparent because now the buffer capacity is going down, it's becoming more acidic. Okay, so that's something I would like you to keep noting here. Okay, so I'm on to my fourth reading, and just to give you an idea, I started at 9.91, and within 4 mils, it has dropped down approximately 0.5, and now I'm at 9.58. So I'm going to continue using 1 mil as I said before. So the previous reading that I read for you was 9.58, and I'm hoping it to be somewhere at 9.5 or something. Yeah, so it was at 9.50. Okay, so let's continue adding some more and more, and I will show you when there will be change in color from being cloudy to a little bit more clear. Just be very, very careful as you're adding the acid into your solution while stirring. Avoid taking those splashes on yourself, because now this is becoming more and more acidic. So I'm just going to let it rest, and I'm going to wait for my pH meter to give me the reading. Yes, so we jumped down from 9.5 to 9.41, still cloudy. Let's see when it hits the equivalence point. And by the way, what is equivalence point? It is when you have equal amount of the solution in your beaker, and then you have added the equal amount of acid from the burette in that solution. That's the equivalence point. And we will cover that again in the lab as well. So far I have added 7 mils and I'm still in 9. So, and I'm at 9.32. So I'm going this slow because I do need certain data sets to plot. As I said earlier too, we will be plotting a graph. So we do need certain data sets so that we can extrapolate the equivalence point half and both PK1 and PK2. I'm still in 9, so I'm going to continue doing it until I reach 8, and then we'll look at the solution again. I'm at 9.18, another mil, and this time I'm hoping I might shoot down somewhere close to 8, but let's see. So I have added so far 10 mils of the sulfuric acid, and if we can zoom in here and compare to, this is the solution I started. I have started losing the cloudiness a little bit just because with 10 mils I have dropped down from approximately 1 pH. Well, rather 2 I would say, because we're going to hit hopefully 8 soon. So the solution has changed dramatically in terms of color. So this was the initial solution, and by the time I hit 9.09, starting from 9.91, this is how it looks like. And this is not where our endpoint is. I still have to add more because this should become more clear. And by the way, remember we started with the carbonate, so we started this equation the other way around where you have carbonate, and that's why it was cloudy, and by the time it's more acidic, close to 3, you will see some CO2 and some bubbles in the solution as well. Okay, so another mil. It looks like, you know what, I'm anticipating I'm going to reach my equivalence point soon for the fact because I see a great change in the color here, the way the solution looks from my last time I just showed you. So we are reaching our first equivalence point soon. I'm at pH 9. And I have 11 mils of acid added so far. So we continue doing this. And don't forget to take note of your readings. Okay, here we are. Just another zoom in here. Look at that. So with approximately 11 mils of acid, we have reached our first equivalence point. Okay. And my reading is into the 8th zone now, so I got the pH of 8.91. So I'm going to continue again. So the way I'm going to interpret this is, we started with the carbonate, reaction with the carbonate, and now remember I told you these species are interchangeable. So now the carbonate has formed into bicarbonate. That's the visual kind of confirmation to that. So I will still doing the same thing, stirring, 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 and let it stabilize. And by then I will start taking my readings from burette. And I'll wait for the pH to display. Okay, excellent. So we are at pH 8.79, another mill. And just to remind you again, I haven't made any change in the volume I'm dispensing. I'm with the consistent 1 ml every time. Okay, so everyone, I did some reading during this time, and I just want to pinpoint the solution the way it looks like, since we saw it at around pH 8, I guess. So I have gone down from, I did some reading, as I said, from approximately pH 8 to all the way I'm at pH 5.7 now. So lots has happened, and we have reached our PK1 already, and we will talk about this in the lab more. But now I just want to show you the solution, the starting solution, and the solution that I have now. And if we can zoom in, and you will see the solution start having some bubbles, means we are moving from bicarbonate towards the CO2, and the CO2 is the one that is a gas, and that has a bubble in an aqueous solution. But I still have to move further. Remember, I said we will be going until we hit the pH 3, so I haven't hit it yet. I'm at 5.7, so I will continue going, adding 1 ml more, and see how far more we have to take the readings. So another thing to pinpoint is I have added 30 ml of the burette solution, which is the sulfuric acid so far. So 30 ml. Looks like it might take another 10 ml. That's my guess. So continuing the same process as before, another ml. Stir, 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 and then let the pH meter do its job. So this is another ml. And I'm already at 5.5, so this is a good change. That's the kind of change I'm expecting. So this is my second ml. Okay, this time, you know what, I have reached this far, and I don't want to take any chances of increasing or decreasing the amount of acid I'm adding in my solution, because I don't want to miss my second equivalence point. Okay, looks like good. I'm at 5.25, and this is where a lot of gonna change happen. So from 5.5 till we hit 3 or below 3, it's gonna be quick one. And this is where you are hitting your second equivalence point, by the way. So another 3 ml. So far we are approximately at 33 ml. And we are already into the zone of pH 4. So I'm at approximately 4.7. I will wait for it to give it a ready button, and I'll enter the final value for that. Okay, still at 4.3. Remember, we have to reach at 3 or below 3. So still more readings. So we just hit the pH below 4. I'm at 3.6. So if we can zoom in, you will see more bubbles had formed since last time we seen. And even if you see the probe, bubbles are forming there just so that you guys can see in here. So we are becoming acidic and we are close to forming CO2 here in our solution. So what I'm going to do is, I'm at a reading approximately 3.37. I'm going to give it another mill and we're going to be below 3 and see what the reading is, and then we'll go from there. My pH is still not ready. I will wait for it. Oh, there it is. So the final, sorry, it's not final. I will take just another reading because we're still at 3.34. So I will add another mill and I'm pretty sure we're going to shoot down our final reading. And that's when we will look at the solution again. And that's what we want to achieve. Yes. I will let my pH meter stabilize and I will speak out the final reading for you guys. Okay everyone, so this is our final reading. I'm at 2.64 and again I will zoom in again. So this is the final solution we were looking forward to. And to remind you again, the equation that we're going to learn started with the carbonate. In between we were bicarbonate. That's when the first equivalence point happened. Remember when this was not this bubbly but still clear, and this is when the CO2 happened. So this was the whole idea, whole game of going from here to here. But you know what? This is what we were gathering. This is our treasure, the data. So we will be plotting this data together in the lab and we will go from there.